F test for equality of two variances. Now we need to do F test for testing whether two samples came from the population which has equal variance. So we need to test on variance, F test, especially for small samples. When size of sample is less than 30, sorry. When size of sample is less than 30, for that samples, to test equality of variances, we prefer F test. So here, it may be any test, we follow these steps, writing null hypothesis H0 and alternative hypothesis, alpha level of significance, test statistic. So finally conclusion. Now H0 is null hypothesis, a hypothesis of no difference. Whenever you are testing on difference of variances, you feel that variance has no difference. That means sigma 1 square equal to sigma 2 square. This is H0, standard H0. If you identify for the given problem, we need to apply F test, then immediately you can write H0, this one only. And H1, it may be one of these, sigma 1 square not equal to sigma 2 square, or sigma 1 square greater than sigma 2 square, or sigma 1 square less than sigma 2 square. Here no need to check one tile or two tile, it may be any tile, getting table value is same. Alpha value generally 5% or 2% or 1% or 10%. Maximum cases 5%, 1% cases we will see. Remaining very rarely we will get. Coming to test statistic. So here F calculated as formula S1 square by S2 square when S1 square greater than S2 square. Or we can write in words like this: greater variance by smaller variance. If S2 square is greater than S1 square, then we take S2 square by S1 square. You know what is formula for S1 square and S2 square? S1 square sigma x minus x bar whole square by n1 minus 1 for sample size 1. Here I equal to 1 to n xi. Similarly, S2 square sigma y minus y bar whole square by n2 minus 1 I equal to 1 to n y. Like this you need to calculate S1 square and S2 square. Which one is greater, that one you need to keep in numerator, smaller one in denominator. Now conclusion for this table value we need to see. Conclusion. F table value for V1, V2 degrees of freedom, where V1 is n1 minus 1, V2 is n2 minus 1. But the F table will be like this. F distribution table, you will find V2 here and V1 values here, V2 values here. Here 1, 2, 3, 4 like that you will have up to 30. Here also 1, 2, 3, 4 like that up to 30. What I am saying, if n1 is 5, n2 is 4, n1 5, n2 4, then V1 5 minus 1 4, n2 4 right, V2 4 minus 1 3. 4 3 degrees of freedom means you need to see under 3, under 4. We will write V1 V2, but we will see V2 under V1. V2 will be in column, V2 in column, V1 in row. So to see the table value like this we need to see 4 3 if you want to see V1 4 V2 3, then you will see In 3 line under 4 you need to see the value. Here you will get the table value. Now compare. F table and F calculated. Compare F table and F calculated. F calculated less than or equal to F table then accept H naught. Otherwise reject H naught. To test the difference of variance and another situation, whenever if you have a question whether the two samples are drawn from same normal population or not, there we have to apply F test and T test. When we can say two samples are came from same normal population, if they have same variances and same means. To test the equality of means we go for T test. To test the equality of variance we use F test. Like that one can decide the samples are drawn from same normal population or not. Or to test the difference of variance only F test is applied. In one sample of 8 observations from a normal population, the sum of squares of deviation, the sum of squares of deviation of sample values from sample mean is 84.4. And in another sample of 10 observation, that means you can observe here two samples. The sum of squares of deviations of sample values from sample mean is 102.6. Test at 5% level whether the populations have same variance. So in the question itself, it is very clear we need to test whether the two samples have same variance or not. They came from the population which has same variance. So it is decided variance test. We call variance test as F test. In any test, these steps are similar: writing H naught, writing H1, writing alpha, and test statistic. H naught, sigma 1 square equal to sigma 2 square. H1, by default we take this one, sigma 1 square not equal to sigma 2 square. Variances are equal, population variance. Alpha 5% given. Now test statistic. In F test you will have 5 or 1% only. Two tables are there, 5% table, 1% table. Test statistic. Before going to test statistic, first write given data. Given N1 equal to 8, N2 equal to 10. Now what is given? The sum of squares of deviation of sample values from sample mean. It can be represented in symbols like this. Summation I equal to 1 to n xi minus x bar whole square is given for first sample. How much it is? 84.4. Sum of squares of deviation from sample values from sample mean. Sum of squares. Similarly, for the second sample also given, yi minus y bar is given 102.6. Now we need to calculate S1 square and S2 square. S1 square is sigma xi minus x bar whole square by n1 minus 1. Its value is 84.4 by n1, 8 minus 1, 7. Similarly, S2 square, sigma yi minus y bar whole square, I equal to 1 to n, here also, by n2 minus 1. That is 102.6 by n2 minus 1, 9. Use your calculator to get S1 square and S2 square values. S1 square is 12.057. In your calc, if you type 84.4 by 7 value, like that, if you type 102.6 by 9, you will get 11.4. Now we need to calculate F calculated. F calculated. To write F calculated, which one is greater, that one we need to keep in numerator. S1 square is greater than S2 square. So formula will be S1 square by S2 square. What is S1 square? S1 square 12.057 by 11.4. So here you will get 1.05 calculated. Next we need to conclude whether we have to accept H0 or reject H0. Conclusion. For this table value, F table value for V1, V2 degrees of freedom. V1 means N1 minus 1, V2 means N2 minus 1. N1 8 minus 1 7, 10 minus 1 9. 7, 9 degrees of freedom, 5% table. So F table for 5% you will have 0.05 F table, 5% table. In this you will have V2 values here, V1 values here. 7, 9 means in 9th line here you will have 7. Here you need to see the value. In the table, F table, this is F table. F table 5%. In that table, 5% table, even though V1, V2 I written like this, but V2 will be in column. That's why in 9th row, 7th column, you will get F table value 3.29. F table, that is. Compare F calculated and F table. F calculated less than or equal to F table except H0. Otherwise reject H0. So some data is given, a random samples gives the following results. Size is given, that is N1 and N2 are given, and X bar, Y bar are given. And also sum of squares of deviation from mean means, this is sum of squares of deviation from mean. This value is given, this value is given. Basing on this data, test whether the samples are came from same normal population. So whenever if you have this word, test whether the samples are came from same normal population. For that, you need to check whether that populations have same mean, that population has same variance. That means you need to do variance test for equality of variance using F test, and T test for difference of means. You need to perform two tests. In the two tests, if you get accept H0 as the conclusion, then we can say the two samples are drawn from same normal population. So first, what we are going to do, F test for equality of variance. Equality of variance F test. Any test, you know, these steps are common. H0, H1, alpha, test statistic. These are common steps in T test also. H0, sigma 1 square equal to sigma 2 square, equality of variance. H1, sigma 1 square not equal to sigma 2 square. Alpha, given clearly, not given, right? Not given. So we need to take the default 5%, 0.05. Test statistic with the given data. N1 10 is given, N2 12, and also given sigma I equal to 1 to n xi minus x bar whole square given 90, sigma I equal to 1 to n yi minus y bar is given 108. Now we need to calculate S1 square and S2 square. S1 square, sigma xi minus x bar whole square by n1 minus 1. that is 90 by n1, 10 minus 1, 9, 90 by 9, 9 tenths, s2 square, sigma I equal to 1 to n, yi minus y bar whole square by n2 minus 1. So this value is 108, 12 minus 1, 11. 12 minus 1, 11. If you calculate, you will get s2 square 9.52. Okay, now you have calculated greater variance by smaller variance. 10 by 9.52. 10 by 9.52, if you use your calculator, you will get 1.018. Use calci. Now the final is conclusion. So for that we need to see F table value. F table value at V1, V2 degrees of freedom. V1 means N1 minus 1. 9, 12 minus 1, 11 degrees of freedom at 5%. F table value. See the table in 11th column, in 11th row, 9th column. F table. If you see that table value, you will get 2.90. Now compare these two. It is clear that F calculated less than or equal to F table. F calculated less than F table. So what is conclusion? Answer is accept H0. H0 is accepted because F calculated less than F table value. This is F test. So what we can decide now, the two samples have same variance. Like this, if we can prove that two samples have same mean, then we can conclude the two samples are came from same normal population. So now we are going to do t-test for difference of means or equality of means. So any test, these steps are same. H0, H1, alpha is same. Next we need test statistic. So H0 is same in t-test, standard H0, that is means are equal. No information regarding H1, mu1 not equal to mu2, 2 times. Alpha default value 5%. Coming to the test statistic, the data is given like this. N1 is 10, N2 is 12, X bar is 15, Y bar is 14, sigma X minus X bar whole square is 90, sigma Y minus Y bar whole square is 108. If you write here I equal to 1 to n. So now we need to calculate S for finding T calculated value. S square 1 by n1 plus n2 minus 2, sigma X minus X bar whole square plus sigma Y minus Y bar whole square. I1 to n. 1 by 10 plus 12 minus 2 into 90 plus 108. Calculate, you will get S square 9.9. Use calculator. S will be root 9.9, 3.15. Now the T calculated will be calculated using this formula. X bar minus Y bar by S root 1 by N1 plus 1 by N2. So X bar is 15, Y bar is 14 by S value 3.15 root 1 by N1. N1 is 10, N2 is 12. So calculate using your calci. You will get 0.74, 0 point some value. If you use your calci, approximately 0.74 you will get. Next, conclusion. So in conclusion, we need table value. Table value. T table value for V equal to N1 plus N2 minus 2 degrees of freedom. N1 plus N2 minus 2 means 10 plus 12, 22. 22 minus 2, 20 degrees of freedom at alpha by 2 level. Because this is a 2 type alpha by 2 level, you will get T table value. T table value 2.086. Now compare 0.74, 2.086. What you will get? T calculated less than T table. What is conclusion? Accept H0. So if you get in both the cases accept H0, then we can conclude the two samples are came from same normal population. If you get both H0, accept H0 you have to get here. Here also you have to get accept H0. Therefore, two samples are came from same normal population. Same normal population. Okay, that is our conclusion. Any doubts you may ask? Pumpkins were grown under two experimental conditions. Two random samples were taken of sizes 11 and 9. The pumpkin shows the standard deviation of 0.8 and 0.5 respectively. Assuming that weight distribution are normal, test the hypothesis that the true variances are equal or not. So here we need to test whether variances are equal or not. That means we need to do variance test. To test the variance, we use a test that we know. Any test it may be, these steps are similar. H1, alpha, writing test statistic. These are same. So test statistic, formula for finding calculated value. H0 null hypothesis. For equality of variance we take variances are equal and variances are not equal. Alpha is not given 0.05. Test statistic, N1 is 11, N2 is 9 and standard deviation S1 is given S1 0.8, S2 0.5. Whenever N1, N2, S1, S2 are given like this, then to find S1 square, keeping this one a small letter, this is S1 square, N1 S1 square by N1 minus 1. N1 we know 11 into 0.8 whole square by 10. This value we calculate using this formula 0.704. Similarly, S2 square can be calculated using this formula N2 S2 square by N2 minus 1. So N2 is 9, S2 square 0.5 whole square by 9 minus 1. You will get 0.281 S1 square and S2 square values. Now we need to calculate F calculated value, FCAL, F calculated. Greater variance by smaller variance. Greater variance is S1 square, smaller variance is S2 square. S1 square by S2 square. S1 square is 0.704 by 0.281. F calculated. F calculated, if you calculate, you will get 2.5. Now we need to conclude. Conclusion. So to conclude, we need table value. F table value for V1, V2 degrees of freedom. Here V1 is N1 minus 1, 11 minus 1, 10. V2 is N2 minus 1, 8. degrees of freedom at alpha level, alpha table, 5% table. There will be two tables for F, 5% and 1%. Now F table value. F table value, if you see like that, you will get F table 3.35. This is table value, this is calculated. Calculated value is less than table value, then you have to accept H naught. That means two variances are equal. Sigma 1 square equal to sigma 2 square. Any doubts you may express.